The half-angle identities is just another set of identities that we can derive using the techniques from this section. In fact, it's probably easiest to derive these from the power reduction identities. Let's start with cosine squared theta is equal to 1 plus cosine 2 theta over 2. Now we're just going to make a couple substitutions. We're going to replace theta with theta over 2. So then we get cosine squared of theta over 2 is equal to 1 plus cosine of, well, 2 theta becomes 2 times theta over 2, and the 2's cancel out, so cosine theta over 2. And now we see that we just take the square root of both sides. Remember, when we take the square root, we have to include a plus or minus. The derivation of the sine one is very similar. Now, when using this, we have one new idea that we have to work with. We have a plus or minus. This corresponds to the same concept from before, where we had to look at the quadrant where the angle is lying in, but in this case we have to be a little bit more careful, because which angle does this refer to? The plus or minus actually refers to this angle here, the theta over 2. And so when you do these problems, you have to remember that you have to pick the plus or the minus based on the theta over 2 angle and not the theta angle. The easiest way to keep this in mind is just to remember, like, we are calculating cosine of theta over 2. This is the thing we want in the end. And so whatever the sign is has to match up with this piece right here. Here's an example. Find an exact value of cosine of 75 degrees. So we have to calculate cosine of 75 degrees. This is not one of our known values from the unit circle table, but we're going to use instead this half angle formula. Now when we look at this, we have to determine what the value of theta will result in cosine of 75 degrees. We are not setting theta to be 75 degrees. And so one of the things you really need to be careful of here is to make sure that you are writing something that matches the formula that we have. Theta over 2. So 75 degrees is 150 degrees over 2. So in this case, the theta is actually 150 degrees. And this throws a lot of students off that are in the mindset of just plugging stuff into formulas without thinking. So take a moment and really think about this to make sure you understand why the theta is 150 degrees and not 75 degrees. Once we get that, we have plus or minus the square root of 1 plus cosine of 150 degrees all over 2. We'll go ahead and calculate the part under the square root first and then figure out the plus or minus later. So 150 degrees. Well, 150 degrees is going to be in the second quadrant, and the reference angle is going to be 30 degrees. Since it's cosine, in the second quadrant it's going to be negative. So this is going to be plus or minus the square root of 1 minus, now the reference angle is 30 degrees, cosine of 30 degrees is the square root of 3 over 2, all of that over 2. So we can go ahead and simplify this, plus or minus the square root of, let's see, we have a 2 in the denominator there, and that's the only thing in the denominator, so, or the denominator in the numerator, and so we can multiply top and bottom by 2. 2 minus square root of 3 over 4. And now we have to make that decision about the plus or minus. Which angle are we thinking about for this plus or minus? Is it the 150 degrees or is it the 75 degrees? Now remember, we are calculating this quantity right here, and this quantity is either going to be positive or negative depending on whether the 75 degree angle is in the first or second or third or fourth quadrant. So in this case, 75 degrees is in the first quadrant, cosine is positive in first quadrant, so we will take the plus case here, square root of 2 minus root 3 over 4. There's one more simplification we can do right here, which is square root of 2 minus root 3 all over 2, because the square root of 4 is 2. Either one of these answers for me would be acceptable. Using the half angle formula to calculate cosine of 75 degrees opens up a really interesting feature. Here's one way of calculating cosine of 75 degrees using the half angle formulas. And here's calculating cosine of 75 degrees using the sum of angles formula. And if you look at the final results, it is not immediately clear that these are actually the same thing, but they are. And you can prove this to yourself by squaring both of these and then simplifying and comparing your results. And so there's a very interesting feature here that we have very different expressions that have the exact same quantity. Now this isn't a course where we can go much deeper into why this happens or how we can create representations like this. But it's interesting to see that it's right in front of us that these two things look entirely different. and it's not obvious that they're the same thing. But because we know they're both equal to cosine 75 degrees, they really are the same thing.